company develops a lot of sophisticated magnetic resonance instrumentation. So it can be like very high-end electron spin resonance spectrometers, pulse spectrometers for various frequencies from 1 to 100 gigahertz. To develop all the hardware and software. And but since we also work on NV centers and ODMR, we sort of developed this I would say reduced version of the system that enables sort of students and other people, even other companies, to use quite sophisticated hardware and software, but still with I would say much more modest prices, and it will be more accessible. So I would say let's go back to the agenda. So let's do first overview of the system and the physical system. Before we go into the setup, let's again explain what are the purpose. So we're in the field of magnetic resonance. We're looking at NV centers. NV centers are color centers in diamond that are very popular in quantum technology. The reason they are popular is that they have 2 electron spins that are quantum species that are unpaired. So under static magnetic field, you can get, depend of course on the magnetic field, but you can get 3 transitions. You have the 0 state, the plus and minus state. So these are the quantum states of 2 electron spins. Okay. The advantage of NV centers is that they can be used as quantum bits or quantum sensors because they have very, very long coherence time, and they can also be optically pumped. So when you shine green light on them, you get most of the population in the 0 state. Okay, so this is like a selective population of this state, like the quantum initialization of a quantum state. And the other 2 states, the plus minus, are less populated. What's also good in them is that you can optically read the state that there are. So what happens is that, again, let's refer to this energy label scheme. When you radiate green light on them, they give red fluorescence. But the amount of red fluorescence depends on where you start with. Okay, if you start with the 0 state, you have usually less fluorescence, and if you start with the plus minus 1 state, you have more fluorescence. You can see it here. Sorry, the other way around. I'll just mix it here. Yeah, you can see it here that when you're in the 0 state, you have more fluorescence, and in your plus minus state, you have less fluorescence. Okay, that is again because of the way those energy levels are being repopulated through some non-radiated transitions here. Okay, I'm not getting into the physics, but the bottom line is that, again, by fluorescence, you can read the quantum state of this spin. And this can go all the way to a single spin. Okay, just a minute. So again, so this is the physical system. It's a diamond with defects. And again, it's not a pure diamond. Pure diamond have pure carbons all the way around. But here you have a defect. It's called a nitrogen vacancy. You replace one of the carbons with a nitrogen, and you also have a vacancy. So these are we have the diamonds in the setup, but it's quite small. Maybe Benji can. No, okay, we won't. You can see it if you want in the internet. There are a lot of examples of the NV centers, and that's very popular. So okay. So what's important is that we want to use it as a quantum bit and a quantum sensor. Let's start with the simplest thing, like a quantum sensor. Okay, what does it mean, a quantum sensor? It can measure magnetic field. How can it measure the magnetic field? When you apply a magnetic field, because those are electron spins, when you apply magnetic fields, they change the energy level. It's called Zeeman levels. So you can see it here. The 0 state does not change because it's insensitive to the magnetic field, but the plus minus states starts to go, one of them